Hello, so in our fourth lab, we will talk about circuits and capacitors. The objective of this lab is measuring and observing the electric circuits is the main focus, and including recording data of the each fundamental parts of the circuit. After that, we could use the concept of loop and node rule to solve problems in this lab. The method that we used is that we used a virtual circuit simulator indicating real-life circuit lab in Java language, and our main result is that we found the time by using both node and loop rule, in which we are able to calculate the reading for ammeter and voltmeter. Physics principles in this lab includes node rule, loop rule, Ohm law, and parallel and series circuits. And our first system is a series circuits in which we calculated the value of the current flowing into the circuit, which is found to be equal to 0.02 ampere, which is similar to the value of the experimental. So when we broke our system, the current should flow back to zero, and the potential difference is equal to the sum of both batteries and volts in series. According to the loop rule, the summation of all potential difference in each part of the circuits should always be equal to zero. Here is the graph for our potential disposition graph. The slope is steepest at A and C and E because the electric field is strongest due to the changes in voltage. In this part of the first system, we put an ammeter which is parallel to one of the resistors. The conclusion of that is that this resistor won't be calculated in our calculation, so the circuits or the current flowing will ignore having a resistor in that location. In our second system is an RC circuit in which we charged a capacitors using a battery, and then we removed this battery to let the capacitor be discharged. Found the time of charging and discharging of the capacitors to be equal similarly. We use the voltmeter graph to calculate the value of our equation. After we recorded the values from the previous slide, we plotted the equation over time, which we found the time or the slope of the time to be equal 0.16, and the time itself is nearly 6 seconds as the actual value, which is 6 seconds exactly. Questions: what if we were on a real life lab? How would our result have changed? First, the ammeter in the lab wouldn't be always ideal like the simulator, so it would have some resistance, messing up our calculation. And in real life, the batteries themselves have resistance, so capacitor wouldn't charge as this fast as in our lab.